That's right. Wow.
All right, everyone, welcome to Lunchalytics. This is our second session in Calgary for 2019. Our first one, if you attended, was a really fun one on hockey, and it was Calgary versus Edmonton, which was always interesting. And so today we're going to be talking about a different topic completely, machine learning. And so we have two really great speakers with us today. Geoff Kliza is the first one, and he's with AMII, which is the Alberta Machine Intelligence Institute, which we'll talk about. And then we have Pavel over here with ATB, so he'll be our second speaker. So before I get started, just a couple of housekeeping items. So as I mentioned, if you didn't get a glass of water, there's a kitchen just at the end of the hall, and they have glasses there. It says Synovus glasses, and they said we're more than welcome to use those, so please feel free to do that. The bathrooms are also just down the hall and on the right. Okay, and so we have been running Lunchalytics in Edmonton for almost 4 years. It's pretty amazing. And we've built together really a community of data scientists who meet up every week, and we have discussions on various topics. So if you have some ideas for topics in the future, happy to meet up with you and talk about that. And the other thing I'm just going to do before we start is just trying to understand who you guys are. So how many of you are data analysts? Okay, how many of you hire data analysts? Is anyone currently hiring data analysts? We actually do that in Edmonton, and we find a lot of people who are hiring and people who are looking, and we actually tend to partner you up together. So it's been really fun to see kind of the growth of data analytics and data visualization come through as part of Dark Horse. That's what we do. But there's also so many other groups now doing that across different industries. So one of the things we talk about all the time is all the tools that you need in your toolbox. So you have regression analysis, lots of other things, but now people talk a lot about machine learning and AI, and it's going to solve all our problems. And so we thought it would be good to have AMII come in and talk to you about what is machine learning, and then some applications, and then ATB will present an application of it that they're using. So I'll turn it over to you.
Thank you.
Thanks.
All right, welcome everybody. So I should have stayed just while you were talking. It's okay. It's only an hour-long presentation. I've been told I have to do it in 20 minutes, so I'm going to talk really, really fast. Actually, so does anybody here not understand what machine learning is? I think you seem like a pretty savvy crowd. All right, that's good. Great place to start. All right, so like I said, my name is Geoff Kliza. I'm with the Alberta Machine Intelligence Institute. So I run the Innovation Affiliates program there, so it's all the work we're doing with industry. So really quick, who is AMII? Well, fun fact, so the University of Alberta is top 5 in the world for artificial intelligence research. The problem is all our grads tend to wander off to other places because there aren't many jobs for them in Alberta. So we're trying to change that. So what we're doing at AMII is we're trying to work with industry to increase the capabilities and capacity in organizations and companies in Alberta to absorb those grads and to create an ecosystem around machine learning and to make Edmonton not only a premier destination for foundational machine learning, but also applied machine learning. So enough about us. Yeah. All right. Any questions? It is a much bigger presentation, but I've had to pare it down. So just really quickly, just to make sure we're all on the same page, this is kind of how we think about machine learning. So what we're trying to do is we're trying to model knowledge, right? So we're trying to create a mathematical model for what goes on in that squishy wetware between your ears. So from information theory, we know we have data, information, and knowledge. So basically what we're doing is we're taking data, we're converting it into information, we consume that information, we map it against our knowledge, and that drives our actions. So we want to create models out of that. So we take the knowledge, and as long as we know what the inputs are, and we know what the outcomes are from the actions we take, we have the information we need to start creating models that we can model the knowledge from. So the easiest way to think about that, of course, is I've got the picture of the cat, it's labeled cat, picture of the not cat, labeled not cat, and using that I can train a machine to recognize cats, right? Pretty simple. Two areas of machine learning, or within knowledge, it's broken down into two areas. So we have prediction and we have judgment. So prediction is kind of the empirical tasks that we do, the numerical-based tasks, the really easy stuff to do. The judgment is the hard things. The judgment is how do we deal with imperfect information? How do we deal with analogous situations? How do we improvise those types of things? So in the world of machine learning, we're really good at prediction models. We're really bad at judgment models. So that's that really quick. Oh, there's a funny picture. There, I'll show you this one because it's fun, right? All you analysts, recognize when you kind of throw the wrong data together, but. All right, so what I figured, since I only have probably 10 minutes left, we talk about the 7 things that you should know before you engage in machine learning. So number 1, define your problem. And you say, Geoff, that's silly, everybody knows that. Stop saying easy things. But it's true. So many people look at technology as a way to circumvent the whole problem of asking questions, and they think technology is just there to give them answers. Who here has read Hitchhiker's Guide to the Galaxy? Yeah, so what was the ultimate answer? 42, right? And then they had to build another computer and wait 8 billion years to answer what is the ultimate question, right? So this quote up there, anybody know who Charles Babbage was? So he's the father of the computer. Charles Babbage, back in the 1700s, built a steam-powered computer, calculator essentially the size of a locomotive that could do addition and subtraction. This is apparently a quote from him I found on the internet, so it's got to be true. But it's like his old-time English way of saying, people are coming to me asking me if I give it the wrong numbers, will it still give me the right answers? How could people be so daft? But I think throughout history, this is the challenge with us humans. We want answers, we want quick answers. And I think that's the problem with the hype right now around machine learning and artificial intelligence. People assume that this is just something that you can take and use, and it's going to give you all of the answers you need to do your business better. So define your problem. And second, and since there's a lot of analysts in the room, machine intelligence problems involve very little machine learning. As everybody knows, data wrangling is probably going to be 90% of the project, right? You got to get your data all in shape and in order. But by the time you've defined your problem, you've sourced your data, you've analyzed the data, you've created your ground truth, you've got your labels for the data. In other words, you've taken all the pictures with cats and called them cat. Then you can finally do your machine learning. You can create some models, which is always the easy part. Once your data is in shape, running models is easy. And then you have to figure out how to operationalize that. How do I put that into my network? How do I lock down my data pipelines? How do I make sure my data isn't going to change? How do I audit the model to make sure it's working properly and not causing mayhem and confusion out there in the real world? So all in, one of the main things is if you go out as a company, you hire a PhD machine learning grad, throw them in your organization and say, go do machine learning. It's going to frustrate the heck out of that person, right? So economics count. I'm an engineer. I live by this. Anything I have to do more than once, I try to automate. And then you typically start dealing with all the edge cases of your automation, and then you quickly get consumed with the automation task, and you forget what you were trying to automate in the first place. A little bit of, ADD maybe. But the economics count. When you're approaching machine learning, you're going to encounter this. The chances of having the right data the first time around that can actually build an accurate enough model for your business purposes is slim. You're going to have failures. You're going to deal with biases in your data that you didn't know were there. You're going to go back to the drawing board again and again. So it's usually, if you're lucky enough and you get the model right the first time, hey, that's great, good for you. You're obviously good data analysts. Maybe your data's in great shape. But there's a good chance you're going to cycle and iterate on this. So make sure the problem you're trying to solve has the right economic benefit for your organization, right? You don't want to try to solve that stupid task you have to do every Thursday. You want to try to automate some big things. Along the way, you may try to solve some smaller problems and get some quick wins. But overall, your big problems, you're going to be working on them for a while. So make sure they're worthwhile. Start simple. A lot of analysts in the group, so you might get a chuckle out of that comic there. But there's going to be biases in your data, of course. And if you start with something too complicated to begin with, you're not necessarily going to see those biases until it's too late. Especially if you jump right into deep learning on day one and you throw all your data at this thing and you think your model's working great, there's some good chances there's some gotchas in your data that are going to bite you. So when IBM team used some deep learning, or I guess just neural networks to train Deep Blue, they train it with a whole bunch of different chess matches, all the greatest chess matches in history, and thinking, hey, this thing's working pretty good, let's go test this out. And so they start playing against some professionals, the computer starts making some moves, and then all of a sudden it sacrifices its queen. And everybody's like, what happened? Why? And you look back through the data and you find out, well, okay, a lot of really great chess matches were won because of queen sacrifices. So it learned the signal that a queen sacrifice equals a game win, right? But it's not the right signal. COPD, so a researcher out of the University of Washington called Rich Caruana did a study back in the late 90s. He put together a project where he was going to take some neural networks and teach it how to do clinical triage on pneumonia patients. So what we wanted to do is try to optimize pneumonia patients getting the right treatment at the right time. So he got his best students and scientists on neural networks. He got together with the best clinicians in North America on pneumonia, and he got all the best data to do with pneumonia. And he put this all together and created a system, and this thing was working like a hot damn. It tested great. It looked like he nailed this thing. It was like awesome. So he said, all right, let's put this into practice. We're going to go and do some clinical trials. So they go out working with some doctors and clinics, and they have the doctor there. They wheel in the computer, and they start bringing the patients in. And so the patient would come in, and the patient would explain to the doctor, here's everything that's going on with me. And the doctor would say, I see, yes. Computer, what do you think? And the computer would give its prediction about what it thinks should happen. And the doctor would be like, yes, I concur. Good job, computer. And then it would move on, and the next patient, and the next patient, until an asthmatic walked into the room. And the asthmatic explains the symptoms and everything that's going on. And the doctor says, computer, what do you think? And the computer says, you're fine, go home. And the doctor's like, no, you hospital bed now. Probably use the word stat, right? Because they're doctors. So this is pretty wild, right? Because you think that asthmatic, they probably need some better care really quick. So they go back, and because they've been using neural networks, you can't just open up the neural network and see where the dial that says asthma is and try to tune it, right? These things are kind of black boxes. So they had to go back to the data and take a look at what the data told them. But the data kind of bears this out, right? Because asthmatics, as it turns out, have an incredibly low mortality rate from pneumonia. But it's probably not because asthmatics have some sort of genetic immunity or superhero powers against pneumonia. It's probably because they have really good doctors who care if their patients can breathe or not, right? So if the asthmatic comes in with pneumonia symptoms, the doctor is probably going to get that patient on the best care possible as soon as possible. So again, you've got this bias in your data, which doesn't necessarily manifest itself when you're looking at the data, because to us that data just kind of makes sense. But the signal that the machine learning learns from that can be kind of complicated and sometimes wrong. So that's why you want to start with your simple models first. Don't jump headfirst into machine learning. Do what you can to learn about your data and make sure that you've got something that's easily understood by the people testing it out. No one cares about your algorithm, right? So in the last, today, machine learning, we're still using algorithms that were invented 40 years ago, right? The secret sauce isn't in the algorithm. The secret sauce is in the data you use for your model. Martin Zinkovich, a researcher at Google, this is out of his 40 best practices for machine learning engineering. Great read if you haven't read it. But as he says, it's not the algorithm that's going to bring you success, it's the features that you use. So really it is all about the data. Know the cost of wrong. Has anybody seen a grid like this before? A risk matrix, right? So you're mapping the likelihood of something happening, what's the probability of something happening versus the impact if it happens, right? And so the idea is if you're up there in the green, it's highly unlikely and only slightly harmful, you're probably safe to proceed. But if it's very likely and extremely harmful, you probably don't want to proceed with that, right? So if you're going to automate with machine learning, you really have to understand what's the impact if your model gets it wrong. Remember, your model's never going to be 100% perfect, and if it is, you memorize the data, and it's not going to work good in real life, right? So if my model was trying to predict the weather or something, or should I take an umbrella to work with me, and the model says I shouldn't and it rains, I get wet. That's not a big deal. But in the case of something like our pneumonia case, if I give the wrong clinical suggestion to the doctor, a patient could end up dying. So that's pretty extreme. And then I gotta check my math here. But so even if your model is like 99.99% accurate, if it's in a place where it's making that decision a million times a day, it's still going to get it wrong 10,000 times a day, right? So, and again, models are never perfect. It's going to get things wrong. So understand what that impact is going to be. And the happy note at the end of the day. So humans and machine intelligence tend to work really good when they work together. And this comes back to this knowledge judgment thing, right? We can machine learn the knowledge part, or the prediction part, but the judgment is hard to model. So humans are really good at the judgment. The machine learning is really good at the prediction. So this comes from a study of metastatic breast cancer biopsies. So that's where you have the cells on a slide, and the pathologist takes a look at them, and then they train a model to look at the slides and try to diagnose if the patient has cancer or not. The pathologist, still better, 96.6% correct diagnosis. The machine learning, 92.5% correct. But when the pathologist uses the output from the machine learning as an input to their decision making, they found they're getting the correct diagnosis 99.5% of the time. And you guys are all analysts and statisticians. You know, yeah, it's a 3% increase over the pathologist's capability, but it's really the other way around, right? It's an 85% decrease in the error rate, which is pretty amazing. So when we think about the future of machine learning, this isn't really about machine learning coming in and displacing people and taking over their jobs. It's really about allowing us humans to do things better, faster, more accurately, right? And if you think about this, you know, this happens time and time again. Back in 1979, when they invented the spreadsheet, there were about 400,000 actuarials employed in the US, right? And the spreadsheet came along. Suddenly everybody said, oh my goodness, these actuarials are going to be out of a job, right? The spreadsheet's going to replace what they're doing. This is going to be mayhem. Can you imagine a whole bunch of accountants with nothing better to do all day? 400,000 of them? This is terrible. It's going to be a travesty. But the actuarials, they really didn't lose their jobs, right? What they were able to do is, using the spreadsheets, they could do their job better, faster, more accurately. They could do higher value things like budgeting, like forecasting, strategic planning. So it really changed the dynamic of what they were able to do. And I really think that's the future of machine learning. Oh, errors. How'd I do? Was that 15 minutes?
Oh, you still have time.
I still have time?
Yeah.
Well, that's actually the end of it.
Okay.
I don't know. Oh, there we go. You changed my slide. Maybe just a couple of quick things I'll mention there. We are creating a training program to certify people to basically to reskill people into machine learning. The first courses for that program are being launched in Edmonton at the Faculty of Extension at the University of Alberta. And the first course is going to run April 24th to 26th. That will be offered in Calgary starting in the fall. It will be probably a 10-course certification program. Basically gives people enough information and enough skills to be dangerous at machine learning. Yeah. Yeah.
Can you give a rough ballpark cost to attend this one? Cost?
There will be a cost, yeah. Yeah, it's, I don't know off the top of my head, I'm sorry. But check back, the information will be up on the AMII website. Yeah. Yeah. But with that, maybe I'll open it up to questions then.
Can I start with a question?
Yeah.
So can you talk about like where you've seen the most success in applications like for machine learning?
With companies who have good data.
Okay.
Yeah. No, I mean, there's obviously, the best success comes from areas where the data already has the information. So when companies already use data to make decisions, obviously it's going to be good. If you're in a situation where an organization is doing domain level research, applied research to learn things about their domain, obviously there's a much longer path than there is with a company who's got business managers who are already doing good analytics, who are making decisions based on quantifiable information. Those are the places. It's very easy to model that, and it starts to get more difficult. The more the more unknown the data is.
Right.
Yeah.
Okay. Did you have a question?
I was going to ask if we could have a copy of this presentation, but I'm not sure if that's available on the website or not.
Yeah, I can definitely.
Yeah, we'll put it on the Lunchalytics website as well.
Okay,
Yeah.
great.
Yeah.
And then, further to that, I guess to that question, like, are there any specific projects you can tell us about that you guys have helped industry with that have shown some success?
It's tough. It's tough. Yeah.
Just too early?
Well, not only is it too early, but some of the projects we're working on, obviously, our clients don't want us talking about the details of them. We're doing a little bit of work in fintech, some work with oil and gas in predictive maintenance. We're doing some work in doing some natural language processing for customer service type of applications, those types of things. Customer service actually tends to be an area that is sort of, I'll call it the lower hanging fruit. Customer service tends to be easy because generally you have good data around your customer interactions, and because it's not mission critical, it's not part of your core operations, generally speaking, it's a good area where you can experiment and learn things without actually messing up the business. It's a lower risk, essentially. Yeah.
Thanks for the presentation. My question is where's all the brain drain going? It's not standard. Do you see a pattern of where people are heading off to it, this technology? It's how you started is people get educated here and leave.
Yeah.
So where are they going?
Yeah, the good news is that we've started to stem that tide. We're actually starting to recruit former grads back to Alberta. So there's definitely a lot of movement happening now. It's really good. Formerly, the grads are going off to Facebook, Google, Uber, Electronic Arts, Microsoft, 23andMe, some of the big companies with, again, lots of data problems, who have big money to throw at data scientists and machine learning scientists. I don't have a statistical background, but I'm also not a scientist. I think it's, you need a little bit of stats, you need to know a little bit of math, you need to be able to program a little bit. I think it's about curiosity. It's about curiosity and, just trying to, keep asking questions about the data you're looking at and what you're trying to understand. I think when it actually comes to machine learning, if like I said, if all the data is prepared, building models is fairly straightforward. There's even lots of great software out there that'll try to build multiple models for you at the same time. But really, it's like I said, it's about trying to find the right combination of features that are going to give your model the best results. Some of that is exploration, some of that is intuition, some of it comes from domain knowledge, right? So yeah, it's hard to say that the best thing. Stats definitely helps, but it's not mandatory, if you know what I mean.
I just have a question about the U of A.
Yeah.
If in the past a lot of students are going elsewhere to work in this field, how did the U of A develop such a significant component of AI and this research?
Great question. Yeah, no, absolutely. So AMII as an organization or as a lab was founded in 2002. So I'll back up a little bit. The U of A is actually the oldest computing science department in Canada and the second oldest in North America. Back in the 60s, Stanford beat us by a month to stand up their computing science department. So we've had a long-standing history of really good computing science. So back in 2002, thanks to the Alberta Heritage Fund and an investment from the Alberta government, they stood up what was then called the Alberta Innovates Centre for Machine Learning. Not as nice a name as AMII, but doesn't quite roll off the tongue. So that investment over the last 16 years allowed the computing science department to recruit some of the best minds in artificial intelligence research at the time, and I think we're just now reaping the benefit of that. So here we are 16 years later, where we've got, pioneer of reinforcement learning, Richard Sutton. Richard Sutton's book on reinforcement learning is considered the seminal publication in computing science. So fantastic researchers, and through the leadership of those researchers, guys like that, Randy Goebel, Jonathan Schaefer, we were able to recruit the next wave of researchers coming in, and it's really just about the critical mass. So we do have one of the most diverse teams. We do a lot of really excellent research given the size of team. We have 14 primary investigators in AMII right now, and we work on a range of precision health, natural language processing, computer vision, reinforcement learning is a big topic there too. So yeah, really just creating the right team and the right team with the right attitude. So they are focused on training the next generation and they care about that. So for instance, at Carnegie Mellon, when Uber came in and it decimated their their computer science staff because they hired all these guys away, our researchers have stuck around. And even though we brought Google DeepMind to Edmonton because they refused to leave to go to London to work with Google DeepMind, they said, well, we'll work with you if you come to Edmonton. So they were able to attract them there. So yeah, it's just a good team.
Okay, great. Thanks, Geoff.
Thank you.
All right, so we're going to transition on to our next speaker. So I'll introduce Pavel Bondarev. He is with ATB, the Enterprise Data Science team, and he's going to be talking about machine learning.
Be here. Hello everyone. You had sandwiches. Likewise, I'll try to squeeze like 1 hour presentation in 15 minutes. Probably it will be longer, so we'll sacrifice Q&A time. And if you have some questions, just ping me later, okay? No. So my name is Pavel Bondarev. I work with ATB as a data scientist, senior analytics manager. My prime role is developing model, of course, machine learning models and natural language processing. And today I'd like to talk about 3 main topics, like personalization for businesses, why businesses needed machine learning in terms of using personalization, and natural language processing, some conceptual approaches. First of all, let's start from the problem. So, because all consumer-oriented businesses have 3 main problems: how to retain customers, how to attract new customers, and how to engage people, spend more money with organization. And the problem is traditional methods and approaches don't work anymore. Why? So if you look at distribution of customers in like average consumer-related organizations, we'll figure out there are around 5% of loyal customers, so people who visit your branches or stores or offices every day. 65% of cross shoppers, so people who just look around and switch brands. Yeah?
Sorry, the mic's not working at all.
The mic's actually for the live stream. I was trying to see if there were mics in the room.
I will try to speak louder.
Okay, thank you.
Or there's lots of seats at the front.
Sorry guys, technical issue.
Technical issues, I know. Where's the... Sorry? It's brighter, but it's not louder. Like, I need it to be louder. I'm just going to press buttons until something happens.
Well, do you need to talk something? Like 1, 2,
Well,
3?
last time it asked me about... It asked me how to...
Okay, anyway, I'll try to do it better. Sorry for that.
No,
So we were talking about, cross shoppers. So customers who...
Hello?
Oh,
Ta-da! Okay.
it's much better
There you
technology.
go.
So cross shoppers, so customers who switch brands all the time. So today you're with FA, tomorrow with Superstore, after tomorrow you're with Costco. And the bottom part, approximately 1/3 of consumers, is gone away customers. So people, or customers who left your business for the past year. And what's the problem with, too loud?
Too loud?
Yeah, what's the problem with the current approaches? Because company usually provides discounts. Doesn't work. Like a waste of time and money. Oh, we even lost our presentation. It's not my day, actually.
You're good. You just got to log in on your computer.
I cannot log in your computer. But I'll continue, yeah. So discounts, they don't work because companies provide some discount to people, usually cross shoppers. People use it and disappear. So in long-term run, it doesn't work in terms of like retention or acquisition of customers. Oh, lucky me. Lotteries, so when companies or businesses offer some big amount of money just to join our business. Doesn't work anymore because people don't like lotteries, don't trust lotteries, and there is someone else who had deeper pocket and can offer more money. ABC exploitative analysis, as known as Pareto law, usually used to build the perfect or ideal customer profile. Doesn't work because companies usually use data about top 5% of loyal customers and build this profile based on these loyal customers and trying to approach same customers. So what's the reason for this? Just make it double loyal? It's unreasonable because the rest is usually omitted. Surveys, reviews, it's nice tools, but usually they very time and resource consuming, and outcomes come with long delay. And eventually it's quite hard to understand your customers in details. So new time requires new approaches, and one of the best and modern ones is personalization. It has many names like personalization, depersonalization, emotional management, emotional connection, and so on and so forth. But main reason for this approach is a capability to recognize and understand customer needs in demand, very precise demands, solve these problems upfront, approach customers, and make them your friends. So just generally speaking, this capability to penetrate into people's mind, understand how people think, look at the world with customers' eyes, and solve their tomorrow's problems. And one of the most important things in this is emotional connection with customers, because people eventually are emotional creatures, and many, if not most, our decisions are made emotionally. Sorry, rather than logically. And the companies which can just build this channel to people's heart and open this heart, they usually get better results. So statistically, loyal customers bring businesses 13% more value, but emotionally connected people bring 52% more value. And if you look at like big companies, like Apple is a good example, it works very well. And we're talking about like banking sector. If you look at the left side of this presentation, here are the numbers. So regardless of what kind of banking services you touch, the pictures and behaviors are approximately the same. And even if you look outside of banking service, like practically any consumer-oriented businesses, the behavioral habits demonstrate the same picture. And this is why many companies started focusing focusing more on personalization and emotional relationship with customers, because they understand in the current world, it's one of the biggest competitive advantage. And one more thing, it's quite hard to copy-paste this solution, because if you develop new product like new chair, your competitor will bring similar one tomorrow. But if you build something invisible, intangible, it's quite hard to mimic it. This is example how it works based on bank. Like for example, I'm a traveler. I like to travel a lot. So when I go to bank branch, teller usually asks me general question, but try to imagine the teller asks me about my plans for the spring or summer. If I'm going to go anywhere, I can spend hours talking about places I visited or I'm going to visit. When I go to website, instead of getting some general information, I see information which resonates with me. For example, like a new car loan, very low rate, quick approval, and so on and so far. And this is cool because in 2 months from now, my car lease is over and I need a new one. When I scroll my Facebook timeline, I see advertisement, which again resonates with me, because it's like a MasterCard for travelers. Use this card, save money, make money, and so on and so forth. So things like this one they make me feel there is something special in this organization, because this organization understands me, this organization hears me, and this organization is trying to solve my problem, current or tomorrow's problem. And again, we're emotional creatures, I start feeling there is something special, and next time when I'm trying to choose which company I want to work with, I'll go to these guys. Just because I feel better, I feel comfortable, and so on and so forth. But, oh, not but, and good thing, people's emotions are quantifiable. So you can measure like loyalty of customers, you can measure retention improvements, so how many people or customers stayed with you, how much money they spent with you comparing to the previous period of time. Also, people are usually spreading the word about your business, and it helps you attract more customers. And this iteration works again and again and again. And as you understand, like the main tool behind all this big machine is machine learning. Because traditional tools like spreadsheets or traditional databases, even traditional algorithms, they don't work anymore. Because we're talking about terabytes of data. In bank, we're collecting information about transactions. It's like billions of records, information about call center communication, information about traveling, and so on and so forth. And machine learning is the tool which helps us better understand our customers, predict their behavioral habits, tomorrow's habits, and meet them upfront. If you look at this cycle, customer communication or consumer communication cycle, like 2 out of 3 items are machine learning based one. But when we are talking about like 3 phases, the first one is understanding. Because in our case, we need to understand who our customers are, what their habits, how they spend their money, where, when, with whom, how much. Do we have any specific factors like weather, which might potentially impact, and so on and so forth. So when we understand our customers, like each and everyone, we're trying to engage these people. And again, trying to approach them in the right time, right place, right message, right person, and so on and so forth. And next stage is learning. So we're trying to make an assessment if we're right or wrong. So if our concept is correct for this particular person, we learn and go to the next iteration. It's an iterative process. It works again and again and again, until we get these customers and, yep.
Is that the pattern that you find with the machine learning? You find that who is the right person to engage?
Are you talking about this stage?
Prediction, actually, yes.
This one?
Yes.
Prediction is on the first stage, like understanding.
So what is how do you find that who is the right person to engage?
Well, for now we're talking about like our customers, because we see, as you remember our first picture, like we're talking about cross-shoppers, our prime target. Because we want to retain these people and we want to keep these people, like these customers, with our bank only. Because we don't want to share them with TD, RBC, and so on and so forth. So we're assuming we have a list of customers who have already been with us. We're collecting this information, we're analyzing their behavioral habits, and then approach them. And by approaching, I'll have a slide for this separately. So by approaching, I mean we are trying to use like omni-channel and target particular person with particular message through multiple channels. That's a good question, actually. I'll touch on this topic a little bit later, okay? So like understanding, as I said before, 2 stages, categorization and prediction. Categorization means who our customers are based on transactions detail, phone calls, communication, social media posts, and so on and so forth. So we're trying to understand who these people are, what they do, how, when, with whom, and so on and so forth. And next step is prediction. So what these people will need tomorrow. Because this is even more important for us, because if bank approaches you with some offer and this offer doesn't resonate with your specific needs, you don't care. And why categorization? Because this is example of the past. Beautiful video, nice advertisement, but conversion rate is close to 0. Because out of 1,600 views, 1,600, only 11 likes and 4 shares. It's nothing. Why? Because it was very generic message for generic group of people. But if you look at people separately, if you target your customers based on their behavioral habits and focus your message on specific groups, conversion rate is growing like 10 times, 100 times. And just briefly, how it works. I believe you're familiar with machine learning. So we're trying to collect information with respect to, well, classify customers based on their spending habits, like grocery, luxury goods, travel, education, and so on and so forth, and categorize customers based on this one, and then predict their tomorrow's needs. It was a great topic in previous presentation that people have to be involved in this process. You cannot trust algorithms, because when my student asked me about like what's the best method, I said, guys, so here is like oil price from 1950 until 2008. What do you expect will be next year price? So everyone said, oh, $150. In reality, it was $30. So prediction includes like both qualitative and quantitative approach. So whatever you do, you have to be very careful, and you need to include experts in all these major. But anyway, so prediction allows us to understand what will happen tomorrow and approach right people with the right message. And like coming back to your question, when we have people, we understand their needs, we started targeting them through all channels, social media, online, website, advertisement, and personal communication. So we're trying just to touch people with specific problem which resonate with them. And if it works, we understand we can retain customers and they will bring more money. So learning and improvement. So if you remember this cycle, the third portion of this is assessment. Because sometimes you build great concept, you believe you predict people's behavior, but doesn't work. Why? We don't know. So this is why we're trying just to collect this information and build future and the past analysis. So how would it work in these conditions? How would it work under these circumstances? And so on and so forth. And then when we improve this model, we go to the next iteration and validate this concept again, or reject it. NLP, like natural language processing, this is one of the core elements of our business because of three reasons. First of all, it helps us minimize operational costs like in half. So instead of like long calls, so customers can use like chatbot and talk to this, because sometimes people call about the same problem but speak with different words. And they spend hours, well, not hours right now, but much time just to get these things resolved. For now, you can collect this information immediately, you can analyze, and you can say, okay, so we have 33 customers on call, and it's just one problem, something wrong with the account. And I said like 3 problems. So it's problem number 1, like time saving and cost saving. Another one is communication with customers, because we need to talk to people all the time. If you remember this guy, Sam Walton, and his phrase, if you don't talk to a customer, someone else will. So we are trying to talk to our customers, because this is the right way to keep people. And the last one, when we talk to people, offline, online, we are capable of building their behavioral habits. Like if people call or like chat with us, everyone has habits. And we use this information just to build next best conversation with these people. And here's just one of practical examples, because when you build an NLP model, you need to use data. And again, I agree with previous presentation. Great data is like 80% of your success. Using traditional approaches like fast text or word-to-vec is cool, but it's too generic and sometimes doesn't work. And this is why we are trying just to reinvent the wheel and use some specific approaches. For example, using collective mind. So here's like one of the examples. We need to build and train model for a particular area, like personal financing in Canada. We use Reddit, Wikipedia, or Quora. In Reddit, there are over 150,000 different subreddits. In these subreddits, there are 100,000 Canadian subreddits. And within these subreddits, we have something related to personal finance. So we extract this subreddit, we extract questions, and train a model based on these questions. Then, when users have some question, we just match them and find the best possible answer based on score, because Reddit is great, it has scores of questions and answers. And this is it. Very simple solution, very quick, and very high throughput. Do you have time? Yeah, and coming back to this cycle, like 3-5 cycle, we have manageable, emotionally driven, personalized customer experience right now. Why? Because we understand our customers, we understand their needs, current and future ones. We can engage customers through multiple channels. We can assess our concept and come back again. So for now, we have a possibility or capability to manage our communication and manage our customers' emotion. And if we can do it, we can make offer they cannot give up. And this is it. So yes, first slide.
Okay, thanks. Okay, so now we'll open it up for questions. Now you know what I really got is ATB really is listening. That's your commercial.
If you don't listen to your customers, someone else.
Someone else will. Any questions on the far side?
Hi, Pavel. Curious.
Do you need mine?
You can't hear me?
Barely.
With this information, how do you make money?
Information, what kind of information?
So do you have, I'm not familiar with this banking, so do you have a profile of your existing customers and let's say the type that's most
So let me,
profitable, makes 60,000,
let me
male, do you take this and you say, how do I win this customer?
Mhm.
Or I'm just trying to understand.
yeah. So if you remember, like the first picture you have, like, right? So loyal customers usually bring more money because they don't share their money with other organizations. If we increase the number of loyal customers, and if we make this customer not loyal but emotionally connected with us, they spend even more money with us. So they are open to admit new services and spend more money with us. So instead of keeping like 3 MasterCards in your pocket, you have one. So MasterCard from ATB. And if you need a car loan, you go to ATB. If you need mortgage, you go to ATB, and so on and so forth. So more people, more money. Does that make sense?
Yeah, I just wanted, thank you.
That was a great presentation. Thanks. I have two
Thank you.
questions. Is that the first one, is your time kind of following up on the previous question? Right now, this customer distribution shows basically a bar that represents 100% of customers.
Mhm.
So is it better to expand within that bar your loyal customers, or to, if you're to assume that bar represents total amount of customers, to continue to grow that bar so that maybe the percentage stays the same if you still grow in that way, which is most profitable?
Yeah, makes sense. Yeah. So this picture is just like average representation. So average distribution of customers within consumer-oriented organizations. But I understand your point. Would be reasonable to have maybe 2 bars and show growth.
Well, I was just wondering in terms of investment of research, because suppose this represented 100 people,
Mhm.
5 people were loyal, and then suppose next year you grew the business to 200 people, so now you had 10 people that were loyal, you had 130 cross shoppers, so the percentages stayed the same. What's better for you as a business to have the growth of 200 and keep these percentages the same, or to keep, say, a mild growth of, say, 120?
Answering simple, both.
But of course, but I was just wondering.
Well, I cannot answer this question right now because each situation is unique. But ideally both. So what we're trying to do is to attract more customers, retain more customers, and engage these customers, spend more money with us.
Because I'm asking from a point of view of somebody who's never stepped in the ATB building facility in my life, but now seeing your presentation and how committed you are to your existing employees, I'm interested. So I'm kind of
Join us.
Well, no, so I'm curious to see if this level of commitment to your existing customers or the cross shoppers, I guess, is what
Yeah.
we're focused on. If that's going to be, again, I don't really watch TV or commercials, so I don't know if your hybrids stuff, but is that level of commitment to your existing customers being used to advertise for new customers?
Yeah, so in opposite to telco, when you just old customer and have nothing, and new customers get new TVs, we act in a different way. So both old and new customers have benefits. So we not just want to abandon our old friends, like yellow friend, and just focus on these blue ones. No, we'd like to keep each and every one.
So I don't have to call to threaten to cancel the subscription if you every 6 months.
Do it as soon as possible, yes. I'll give you a phone number and call.
All right, thank you.
Yeah, sure.
Yeah. In the front.
So I'm wondering, you have multiple avenues that you're pursuing in order to grow your customer base or add new customers, convert them to loyal customers, are you able to track a particular avenue of attack with the growth in that particular avenue? Or because you're attacking so many fronts, you just sort of get a general number as to the increase in your growth?
Good question. So actually, I'm not marketing guy. I'm just a data scientist.
But it's
So
data.
well, we're trying just to. It's not like a good example, but we're trying to boil the ocean. Of course, it's not right and sometimes, but for now, we're at the beginning of this process. So we're trying to experiment with many things, multiple solutions, because in this world, there are lots of unknown things. You don't know that you don't know up until you try it. So this is why we're trying to play with NLP, we're trying to play with customer online behavior, offline behavior, transactional behavior, multiple things. Which one will work? It's hard to predict right now, but my guess, we will just combine and like combined effort will bring like 10x output, just because we
So
just.
no way to say at the moment that this approach is better than this one. It's kind of like all night.
Well, luckily we're not startup, we're big organization, which can, afford having like multiple teams focused on different directions.
Last question, then we have to go. Sorry.
Just going off like that simple mindset, what would you say is kind of like your quickness to kind of prove machine learning?
Sorry, can you repeat it, please?
Yeah, go over some of the simple things that you have to with machine learning.
So-
Just showed out.
Yeah, so for now, like my particular role at the current moment is NLP, like natural language processing. And I'm building models which help the organization communicate with customers, like online, offline, and so on and so forth. So what we're trying to do is we want to build a channel to simplify this communication process. So if you have some issue, technical issue, account issue, whatever, your problem has to be resolved immediately. And this is what we're trying to do. We would like to minimize the time you spend to resolve this issue, and we want to minimize the amount of funds we'll spend to resolve this issue. So like, this is our current goal right now, like automation, optimization, simplification, and so on and so forth. As soon as it's done, next step, we'll be going to like dive into deeper things, more specific solutions and so on. And one more question.
Really quick.
All right, really quick, Greg.
So
Just kidding.
everybody's becoming aware that data is being used. I mean, all of our data when we're out there are actually being used for everything. And is there fear of a backlash? I mean, if I walk in to talk to an ATV teller and they ask me, hey, how was your vacation, or how many kids do you have? And I answer that, and then I realize they're just typing that into a machine learning algorithm.
No, it doesn't work this way.
And ultimately, that's what you're trying to do, right?
It's quite the opposite. So when you just enter the door, she or he has already know you and has like three, like lines. So John Doe travels, dogs, kids. She doesn't need to type anything because it's
She already
open
knows.
world. You share this information with the entire world already, right? And what we need to do is just grab this information from open sources and understand it.
Right.
And when you talk, you'll be asking about your travel, about your kids and your dog.
Okay, I see what you're saying, yeah.
If you're happy, you will come back next
As long as
time.
it's not contrived, right? As long as that relationship's not completely
Well-
contrived, because that's going to push people away, I think.
We are not Facebook plus Cambridge Analytics.
Yeah.
Okay. Thank you. Thank you for your presentation. So I know everyone has to get back to work, so I'll end it here, and both presenters will be around for the next 5 minutes if you want to chat. Next session in April, it will be on April 2nd, and it's going to be on visualization. One of the presentations will be by Wesley Willett from the U of C, and then the second presenter we're still determining. So if you have anyone that you know within the community who does viz work, then let us know if they might like to present at Lunchalytics. And then May, we haven't quite figured out, but we will figure it out in the next couple of weeks. So if you have any ideas for us, then let us know. Thank you.